In this video lecture, we'll be solving this problem: remove all adjacent duplicates in a string 2. It is a Leetcode medium problem. In this problem, you're given a string s and an integer k. A k duplicate removal consists of choosing k adjacent equal letters from the given string s, and we remove them, causing the left and right side of the deleted string substring to concatenate together. Fine. We repeatedly make k duplicate removals on the given string s until we no longer can. We have to return the final string after all such duplicate removals have been made. It is guaranteed that the answer is unique. So there are no multiple answers for a given test case. In the example, we'll be given a string s and integer k. In the output, we have to return a string which is obtained after k duplicate removals on the string s. The length of the string may go up to 10 raised to the power 5, while the length of the window which we have to remove goes up to 10,000. It is guaranteed that s only contains lowercase English letters. So let's better understand the problem statement using an example. So here we have the string s and a k integer. K is 3. We have to take 3 consecutive integers which are same, and we have to make repeated removals. Fine. So let's start from this string s. You can see that first we have d, and there is only one such character in this string, so we can't remove it. Then we have e, and we have 3 consecutive e's, and which is equal to the size of the window which we are given. Hence we can remove this window, giving me a string of d. So this is the string which we obtain after removing these 3 e's. Then I can see that I can remove these 3 c's because we have 3 consecutive c's here. After we remove these 3 c's, we have our string as d, b. So after we remove a window, the left substring and the right substring are concatenated. Then here we have b as a valid window which can be removed, giving me a string of d, a. Then I have this d window again which can be removed, giving me a final string of a. So this is my final string, and I cannot remove from this string, and hence this is my answer. So how can I solve this problem? It seems pretty easy. All we have to do is to take out k consecutive characters, remove them, take the left and right substring after removal, concatenate them, and repeat the process. How can we perform this? Let's see the intuition to solve this problem. So let's try to build the solution for this given problem. This is my sample input test data. This is my sample input string and a window size k, which is 3. So let's traverse the string from left to right, and we count the number of similar adjacent characters. So initially we have d, and we have its count as 1, and let's say we put it into a container. Fine. Then the character changes at second position. So once the character changes, I check if the character which I previously had in the window matches with the given condition of the problem. That is, if we have consecutive similar character with a window size of 3. And the answer is no. D is not. We do not have such character. So we move to next character, and we see we have a character which is not matching with the previous character. So E is not matching with D. So we push E with its count into the container. Then I move to the next character, and I can see that the next character is same as the previous character which is present at the top of this container, and hence I increment its count to 2. Then I move to next character, which is E again, and it is again same as the top character of the container, and hence I again increase the count of this E to 3. Then I move to the next character, which is D. I can see that this character is not same as the previous character, so E becomes 3 here. Now what I observe that the count of the character E becomes equal to the window size that we are given in the string, that is k. Hence I can remove this character from the given container. So E is removed. Fine. Now we have D only. Then the next character is D, and you can see that the top character of this container is also D. Fine. So we have removed this window of E, and the top character becomes D now, and this top character which is present in this container matches with this D. Fine. So that's why I'm using this container, so that I can check the top character of which is present in that container with the current character where we are standing. Fine. So it is basically giving me a first in last out kind of functionality. So I pushed D first and I am comparing it here with the fourth character after I have processed the characters which are in between them. Fine. First in last out type of functionality. So I can see that this character D is matching with the top character of this container, and hence I increment D by 1. So T becomes 2. Fine. So the string that we are processing in this container is DT now. Then I move to next character, which is B, and this is not matching with the top character of this container, and hence I push a new variable, I push a new pair for this character with its count. Then I move to next character, which is again B, and this character matches with the top character of the stack, and hence I increment the count of this character by 1. Then I move to next character, which is again not matching with the top character of the stack, and I can see that the count of this top character is less than k, so I cannot even pop it. We do not have the enough similar characters so that we can move a removal operation or a pop operation. So I move to C, and this is again a new character, so I push C with 1. Then I again move to next character, which is again C, and it is matching with the top character of the container, so I make its count to be 2. Then I move to next character, which is again C, so again I make its count to again here C becomes 3, so I have a chance for removal. It is duplicate deletion, so I remove this pair from the stack. Fine. Then again I move to B, so here again the top character is matching with the B on which I am currently standing, so I have processed the string which is in between here, that is CC, and again this BB which I stored here is matching with the character which I obtained after removing these 3 characters. So now I can process this B. So B becomes 3 now. So B becomes 3 now, and since B becomes 3, I can remove this window. So I remove it or pop it from the given stack. Then I move to next character, which is character D. So I can see that the top character of this container again matches with this character D, and hence I increment its count by 1 again. So D becomes 3. So since D becomes 3, it can be removed again. So I pop this element from the stack. Now I have my empty stack and I am standing on character A. So I push A with its count, that is 1. Then again I move to next character, which is matching with the top character of the container, and hence I increment the count of the character by 2. And finally I process my entire string, and here in the stack I have my remaining string, which is just A repeated 2 times, and this is the answer. So you got the idea how we solved this problem using mere a container which supports a functionality of first in last out. We have 3 things here. We take a container, we traverse the string, we push the characters as they come into the container along with their count, that is consecutive count. So if we have 2 consecutive characters which are similar, then we push those characters, let's say C, with its count. If the count becomes 3, then that means this character can be removed from the string, and hence the window is removed right there. In this fashion, the given container processed the string from left to right. Finally, after I have processed all such windows, I will have my remaining string present here, that is each character with its count. Like in this case, after we have made all the removals, we have A present in this given stack, in this given container. So which type of container can we use to support this kind of functionality? And the answer is simple. We have stack to support this kind of functionality. Like in this case, we remove this window of CCC. Then I want to make sure that the next string BDAA must be concatenated with the previous string. Fine. So this BB must become adjacent to this B, and that can be done using a stack, because in the stack I already have B pushed with its count. So B is pushed with 2, and then I encounter a new B. So I can simply pop this element from the stack, check if it matches with the B here. If it does, then all I have to do is to increment the count to 3. It is saying that the new string that I have will have B 3 times repeated while C have been removed. So that's the idea. Let's see the implementation for this problem. So this is my remove duplicates function. Takes the string S and a K. I declare a stack st and a count variable which is initialized to 0. I calculate the size of the given string. I traverse the given string from left to right. If we have empty stack, we simply push the current character with the count, which is 1, and then I continue right from here. Otherwise, if the top of the stack contains the same character as the current character, in that case I simply increment the count of the character which is present at the top of the stack by 1, and if the count becomes k, then I remove that character. Otherwise, if we have a new character encountered, then I initialize count to 1 because we have one occurrence of a new character, and I push the new character with its count into the stack. Finally, after we have processed the entire string here, I iterate over the stack till the stack is not empty, and I simply pop all the characters from the stack, generate a answer string right here while decrementing the count of each character. So what I'm doing here, let's say I have a stack. In the remaining string I have, let's say, character C2, then I have, let's say, E1. So this is the remaining string which I have in the stack, and while in this loop what I'm doing here is I'm simply iterating over this stack. So I pull the top element from the stack and I put it here, so this is removed. Then I again pop the top element which is C, and I have to concatenate it 2 times. That's what I'm doing here. I concatenate this C 2 times. Now I have ECC while the initial string was, while the string must be CCE, because I have pushed the characters from left to right string. So I have to reverse this string. So then here I perform my reverse operation, that is CCE, and this becomes my final answer, and I return that answer right from here. Fine, so this is how this function is working. Let's see the code implementation for this. So here we have my solution class in which we have my remove duplicates function. In this function I first initialize a stack of pairs st, and I initialize a count variable to 1. Then I push this, then I calculate the size of the string, and I iterate over the given string. And here I check if the stack is empty. In that case, I simply push the given character into the stack, and I continue right from here. Otherwise, if the top character of the stack matches with the current character, then I simply increment the count of the top character by 1, and I check if this count becomes equals to k. So if it becomes k, then I simply pop this count. Then I pop this character from the given stack. Then we have my final condition, that is the top element does not match with the current element. In that case, I simply push this element. I simply reinitialize my count variable to 1, and I push this new character SI with the new count, which is 1. Fine. After I have processed my string, I simply iterate over the given string. And finally, I reverse my string answer, and I return this reverse the string right from here. Fine. So this is how this remove duplicate function is working, and this is the implementation in C++. Let's see the implementation in other language. So this is the implementation in Java, and this is the implementation in Python language. So let's discuss the time and space complexity for this problem. You can see that since we are iterating over the entire string exactly once, the time complexity for the given approach is big O of n. The space complexity for the given approach is also linear big O of n, because I'm using an auxiliary stack which consumes a linear space, because stack is a linear data structure. Fine. So that's all for this video. If you like the video, then hit the like button, and make sure to subscribe to my YouTube channel, and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye.